One of the greatest obstacles to crafting health and wellness is identifying and controlling inflammation. It's at the core of all complex and chronic diseases, and it's the driving mechanism that underlies the most common symptoms that people like you struggle to overcome. Join us as we explore cutting-edge science and research to give you the information and tools you need to create the quality of life you want and deserve. And now, here is the host of Inflammation Nation, Dr. Stephen Noseworthy.
Hey guys, and welcome back. So one of the core themes of this podcast, of course, is inflammation. After all, that's the name of the podcast, right? Inflammation Nation. So we talk about where it comes from, how it affects your health and your wellness, and how to deal with it. Today, I thought I would talk about my new favorite lab test. This is called the Advanced Oxidative Stress Test, and how that might help you gain some visibility into how your inflammation and your inflammatory load is affecting you all the way down to a cellular and a subcellular level. We talk about being inflamed all the time. Do we know what it means, and can we actually really quantify that? Now, before we talk about the test, how you can get it for yourself, let me hit the highlights of a couple of core concepts. I'm going to cover inflammation itself, and then I'll talk about this thing called oxidative stress. And the first thing to know is that these two things are different, but they're intimately linked together. Inflammation causes oxidative stress, and oxidative stress causes inflammation. And so while they are technically different and biochemically different, because they are so connected, I want you to think of them as two sides of the same coin. So when I talk about inflammation, it should be understood that I'm including oxidative stress and vice versa, right? Because you can't really separate them. Okay, so let's talk about inflammation. From a technical standpoint, inflammation is a complex biological response to some kind of a harmful stimulus. That can be an infection, it could be an injury, it could be exposure to some environmental toxin. And in most cases, when we talk about inflammation, we're assuming that this is coming from the immune system, and for the most part, it does. But there is something called neurogenic inflammation, which actually involves your brain and your nerve tissues generating inflammatory chemicals without the immune system being involved at all, at least not in the initial response. And this neurogenic inflammation has been studied in like headaches, chronic fatigue, certainly fibromyalgia, and we know it can happen as a result of neurological injuries such as mild traumatic head injury or simply concussion. And now that I say that, sounds like a great topic for another episode. But for now, let's stick with the more common understanding of inflammation as being a coordinated multi-system response to some kind of a noxious stimulus where the immune system plays a central role. And when we look at it that way, we can say, well, inflammation comes in two flavors, right? It comes in acute and chronic. And one is useful, it serves a purpose, and the other does not. It actually creates issues and problems. So the acute form of inflammation is a desirable and productive immune response that allows us to target and eliminate, for example, infections. It also helps us to heal from tissue injuries. And this acute response is designed to be self-limiting. And without getting too deep into the weeds here, once the immune system reacts to an acute infection or injury, there is co-activation of a certain class of cells that oversees the immune response, oversees the inflammation, and then shuts everything down when the job is finished. And I've talked about these cells before. These are regulatory T cells. I might refer to them as Treg cells from time to time. The phrases can be used interchangeably. Another name that you might come across if you're out there on the internet and the blogosphere is the Th3 system. So they're all talking about the same thing. And these cells are absolutely critical to this self-limiting aspect of acute inflammation. So remember, when acute inflammation or with acute inflammation, the purpose is for the immune system to temporarily elevate against an infection or to help injured tissue heal. But when the infection is gone or that sprained ankle is healed, then the acute inflammation subsides and everything goes back to the normal resting state until another infection or another injury happens. And by normal resting state, I don't want you to think that healthy people don't have any inflammation until they do, because, they might have an infection or an injury, but no, like at a very low level of inflammation, I should say a very low level of inflammation and oxidative stress is a normal part of healthy human biology, right? It's actually part of what stimulates your cells to continue working and to continue repairing themselves. And we'll talk a little bit more on that in just a little bit. So with healthy people, they have a baseline of inflammation, which increases when required, but then returns to that baseline whenever the threat or the damage is gone. And that's normal baseline and acute inflammation. But chronic inflammation is another thing entirely, right? Chronic inflammation happens under two general conditions. The first is when the normal shut-off signals don't happen and what started out as acute inflammation continues longer than it should. And there are several things that can do this, but one thing is failure of these Treg cells to do their job. And that failure of Treg cells can happen if you have a lower population or a fewer number of Treg cells that you're supposed to have, or if you have Treg cells that don't have the key nutrients and the things that they need to keep functioning at a very high level. So you can have a deficiency of Treg cells, or you can have an adequate number, but they might be incompetent or they might be inefficient. And this Treg cell deficiency can happen simply as a result of pursuing and adopting an unhealthy lifestyle, which would include a pro-inflammatory diet, poorly controlled stressors, lack of exercise, and so on. But it can also happen with environmental toxins. But one of the most common causes of low Treg cell count is a bacterial toxin called lipopolysaccharides. And again, I've talked about this in other episodes, but these lipopolysaccharide, we say LPS for short because it's just too long to say lipopolysaccharide all the time. These inflammatory bacterial toxins are created by certain types of unfriendly bacteria that can live in your gut. So think bad diet, no exercise, poor adrenal function, gut infections, and perhaps a higher than normal toxin load. These things can lead into regulatory T cell dysfunction and a lack of control over shutting off the inflammatory response. And by the way, the only test that I'm aware of that gives us any data about Treg cell populations is the lymphocyte map from Cyrex Labs. And you can check that out in my lab shop if you want to. The link is in the description to the lab shop, and you can go in and read it, or you can go to cyrexlabs.com. That's CYREX. I don't have any affiliation with them other than knowing some of the people who are behind the scenes that are creating the test. They're PhD immunologists and so on, but I don't have any financial interest in that company. Now, the other part of this is that sometimes you have a normal number of Treg cells, but they might be inefficient or incompetent. And that's like having, let's say you have poorly trained staff at a job where, sure, you have the right number of warm bodies, the right number of people to fill all your positions and do the work, but maybe the ones that you have don't really know what they're doing. Right? Maybe they're new hires. Maybe they've never worked in that industry before. Their skill level is lower than it should be. The results are the same. Whether you have lower amounts of regulatory T cells or whether you have incompetent T regulatory cells, the outcome is the same. And that is the inability to control and shut off the acute inflammatory response such that inflammation then becomes excessive or chronic or perhaps both. And while there are several possible reasons for this, as always, we know a couple of things for sure, that deficiencies of both glutathione and vitamin D can transform functional Treg cells into incompetent Treg cells. Let's call them Treg cell dummies who lose their expertise. They forget what they're supposed to do and how to do it. So the first thing you need to know about vitamin D deficiency is that deficiency and insufficiency are rampant. And the more inflamed and metabolically dysregulated you are, the more depleted your vitamin D becomes because it gets consumed in the process of trying to control and coordinate your immune system. And again, I've said this in other episodes before. I check vitamin D status on all of my new clients, at least in the beginning. And across the board, the only ones who start out having good vitamin D levels are the ones who are already taking it for whatever reason, right? And so if you are unwell and chronically inflamed, it's almost guaranteed that your vitamin D levels are lower than perhaps they should be. And what is the number? I think you should shoot for your 25 hydroxy version of vitamin D to be maybe up around 80 or 90 on a consistent basis, right? So if you don't know what your vitamin D levels are and you are unwell and you think you're inflamed, get your vitamin D levels checked and do something about that. Now, you might be saying, well, I don't have to do that. I spend a lot of time outside. Like maybe you're in Florida, maybe you're in California, maybe you're in a place where it's sunny all the time. It does not matter. I'm telling you that I see as many people with low vitamin D status in every single state and in different countries. It does not matter how much sunshine you get. We have a depletion and we have an insufficiency of vitamin D almost across the board, right? So I'll just ask you to trust me on that and go look, right? Go get it tested. So that's vitamin D. As for glutathione, let me hold off on that until we get to the oxidative stress test. And we'll talk a little bit more about glutathione, why it's important, and how we can test for it. Now, as regard to just inflammation in general, we certainly can test for inflammation with standard tests, standard blood tests, looking at what we call acute phase reactants. Now, acute phase reactants are lab markers that either go up or down based on your inflammatory state. Right? You may have heard about standard lab markers like C-reactive protein or high sensitivity C-reactive protein, or something called the ESR, or the erythrocyte sedimentation rate. These are the ones that probably your medical doctor are going to look at to see if you're inflamed. And if they're normal, they're going to tell you, well, you're not inflamed. And maybe that's true. But how can you tell someone who is chronically fatigued with unexplained joint and muscle pain and brain fog and depression? How can you tell that person that they're not inflamed? Because these are inflammatory problems, right? How can you tell someone with insulin resistance or metabolic syndrome or prediabetes and diabetes that they're not inflamed? It's part of the problem. By definition, they are. So sometimes there's a disconnect between your inflammatory state and how your body expresses that in the things that we commonly test for. And I think the mistake that a lot of conventional doctors make is looking only at those two classic markers, the C-reactive protein and the ESR, and as if those were the only things or only places to look for the inflammatory process. It's like if my wife and I were heading out to the car to go somewhere and she asked me to check the house because she left her cell phone there. If I just go to the front door and poke my head in the living room and look around and come out and tell her that her cell phone's not in the house, she's probably going to roll her eyes at me and ask if I checked everywhere, right? Maybe her cell phone is in the kitchen. Maybe it's in the bedroom. And I didn't find it just because I didn't look in enough places. And that's what happens when conventional doctors only check C-reactive protein and the sedimentation rate as indicators of inflammation. Now, if it's helpful, here's a short list of other inflammatory markers that your doctor could test for if they knew a little bit more about health and function, right? And I'll stick to the more common ones that docs will probably be looking at on a routine basis. But for you, just know that there are more, but some of the inflammatory markers that are published in the medical literature, they're just not common tests. Right? We don't run them on a frequent basis. And so we just kind of stick to the ones that we do look at on a frequent basis. So as I said earlier, some lab markers go up in inflammation, others go down. Things that go up we call positive acute phase reactants. Things that go down we call negative acute phase reactants. And so as it relates to things that go up, by far the most common marker that we see go up in inflammation is something called ferritin. Ferritin is actually a test for iron sufficiency. It's a better test than just looking at your serum iron itself. If you don't know why, serum iron, or what's commonly referred to as iron, represents only about 1% of all the iron that's in your body. So we can't really get a good handle on what your iron, whole body iron status is just by looking at serum iron. We look at this thing called ferritin. And ferritin is actually iron that is bound to a carrier protein called apoferritin. Not to get too complicated, but that's what it is. And so what happens with inflammation, there's an increased production of a liver-based enzyme called hepcidin. And hepcidin basically increases the storage of iron in this form of ferritin so that things like viruses and infections can't use iron in circulation to their benefit, because some of these organisms do. They scavenge your own iron to use it for themselves and take it away from you. And so in the innate intelligence of the human body, when you are infected and inflamed, if there's a microorganism, for example, that's driving the inflammatory response, your body makes this thing called hepcidin, which then allows you to take iron away from the organism and store it so that they can't get to it. It actually is part of the coordinated immune response itself. So when ferritin levels are high, we think inflammation. Doesn't tell us where, doesn't tell what causes it. We just know that there's either an infection or some inflammatory response. So that's the most common one that goes up with inflammation, other than the C-reactive protein and the sedimentation rate. But some tests go down with inflammation. And these, again, are called negative acute phase reactants. One of the common ones is called total iron binding capacity. And this is another marker that's related to your iron panel. It's if your doctor orders an iron panel, the TIBC is going to be there. Some labs will include a ferritin. Other times that has to be ordered by itself. But the TIBC, total iron binding capacity, goes down when the macrophages of your immune system basically engulf this protein called transferrin to prevent infections from using iron. And you can see a recurring theme here. Like, iron is very important in the biology of infectious organisms. And so your body should be doing everything it can to take iron away from these organisms so that, again, they can't thrive. Again, it's part of the immune response. So ferritin can go up, TIBC can go down. So sometimes all we have to do is look at someone's iron panel, add a ferritin to it, and then look at those markers to see if we're seeing evidence that there's an inflammatory response. And if those things are positive, even if someone has a normal sedimentation rate and they have a normal C-reactive protein, even the high sensitivity one, if that's normal, it does not mean they're not infected. It just means that they're not expressing their inflammation in that way, because there are other ways to express that. Now, one more test marker that can go down with inflammation is albumin. This is the major protein that's made by your liver. It functions as a protein and a hormone carrier. It just does many different things. That's not the point. The point is it can go down in inflammation to conserve amino acids that are used to increase other inflammatory markers that require them. So in order to make these biological signals that there is an inflammatory response, some of these require amino acids to make. And so basically your body says, okay, I'm not going to make as much albumin, or I'm going to take the albumin, break it down, get the amino acids, and make other things that can tell everybody that, hey, we're inflamed, right? So ferritin can go up, TIBC, albumin can go down. There's one other test of inflammation that I want to talk about, which can actually go either direction. This is interesting, right? We have numerous studies about HDL, right? This is the lipoprotein that people call the good cholesterol, and it does often go down in inflammation. This is very well published, but in some cases it can go up. And that is going to be dependent on other factors. And so inflammation by itself can actually turn on an enzyme called paraoxidase. There's actually 3 different versions of this, but paraoxidase 1, its role is to protect HDL from being damaged and degraded. This actually helps combat inflammation, especially if the inflammation is associated with environmental chemicals like pesticides. The paraoxidase is known to upregulate, particularly with things like pesticides and herbicides, and that can actually preserve your HDL population so that it does not go down and can actually go up. So just to recap, inflammation is a complex coordinated response wherein the immune system produces chemicals that help the body heal from injury or get rid of infection. And under healthy conditions, Treg cells control this response, and they tell everything to shut down and go back to baseline when the job is done. But sometimes these Treg cells fail, and inflammation becomes excessive and or chronic. And we can pick up on inflammation just by looking at a spectrum of common lab tests that can change, and not just poke our head in the door and look for the cell phone in the living room. Right? In other words, sometimes inflammation shows up as CRP or sed rate or ferritin or changes in your HDL or albumin or the total iron binding capacity. So the next time your medical doctor says you're not inflamed, ask him or her if they looked in the kitchen. Did they look in the bedroom? Did they look in the basement? Did they look in all the places where they could potentially find evidence that there is an inflammatory response? All right, let's move on to the other side of the coin, and that is oxidative stress and free radicals. A free radical causes oxidative stress, which is the damage that free radicals cause to your cells. Right? So in general, a free radical is an atom or a molecule that has an unpaired electron, making it highly unstable and highly reactive. And the core concept here is that atoms and molecules, they like to have an even number of electrons for stability, and they don't like having unpaired electrons. And what that means is that when a free radical with an unpaired electron interacts with something else, like tissues in your body, it steals an electron from that thing to stabilize itself. And this is then what stabilizes and causes damage to whatever that thing to which it is bound or it interacts with. So again, in general, free radicals cause oxidative stress and damage to your cells, specifically your cell membranes, your cells' mitochondria, and even your DNA. And this is a huge deal, right? Free radical damage via oxidative stress is implicated in common theories of aging. And we know that when we damage cell membranes or mitochondria and DNA, we see poor cellular communication. We see fatigue because we can't make ATP, and we see aging, accelerated aging responses. And this is typically on a global scale. These are system-wide responses. So if we dive a little bit deeper, when inflammation and free radicals cause oxidative stress, which then damages your cell membranes, it affects both the lipid and the protein structure of your cells. And that stiffens the cell membrane, which changes how vital nutrients and other elements of healthy biology can flow into and out of your cells. It also changes how your cells respond to intra and extracellular signals that are part of the communication pathway that regulates all aspects of your metabolic state and keeping different systems connected to each other. Free radicals generated from inflammation also cause oxidative stress and damage to your mitochondria. And if you don't know what that is, it's the energy producing factory inside all of your cells, with one exception. Your red blood cells don't have mitochondria. They produce energy through a different mechanism. But inside your cells, you can have hundreds to thousands of mitochondria that are all connected in a sheet-like or a net-like fashion. Right? It's not like your mitochondria or your cells have one mitochondria. They can have hundreds or thousands. And in a twist of design, it's actually the process of these mitochondrial networks creating energy to fuel cellular function that produces the largest portion of the free radicals that we produce through normal metabolism. And that means, just like you have a baseline of inflammation that is simply a part of normal healthy biology, so too do you constantly generate low levels of free radicals that are simply a byproduct of being alive. Right? Healthy people have two things working in their favor. I mean, obviously more, but two things I want to talk about here. First is that they produce a normal amount of free radicals that are not excessive. And second, they have adequate antioxidant capacity to dampen free radicals and to control the oxidative stress and the damage that comes from that. And it turns out to be healthy that you have to have a baseline of inflammation and a baseline of free radical production to trigger your body's defense and repair mechanisms to keep you healthy. Right? It's when you produce too much and you can't control it that things can go wrong. So with these mitochondria, which makes energy for all cells except red blood cells to function, they make free radicals all the time under normal healthy circumstances. But if we can't control the free radicals, and then they turn around and damage the mitochondria and reduce their ability to create energy, and some of that energy, should be produced, is not being produced. Some of that energy is actually needed to make antioxidants. And so with free radical damage to the mitochondria, energy goes down, antioxidant production goes down, and oxidative stress goes up, and the whole picture just gets worse. It's a self-perpetuating problem. And what this means is that when you're unhealthy, there's a good chance that your inflammatory and free radical loads are too high. And that part of your health issues are coming from this inability to prevent damage to your cells, your cell membranes, your mitochondria, and energy levels, and even your DNA. Now, to understand this part of the inflammation oxidative stress coin that has two sides, you need to know a few basic things. First, DNA contains the instructions for the cells that tell the cell what to do and how to do it, right? DNA is often described as the software that runs your hardware, right? Software that runs your computer, your iPhone, your tablet, whatever. And as you know, if you damage or corrupt software code, then whatever programs you're trying to run either spit out nonsense or they simply just don't work at all. And the same thing happens when DNA damage comes from free radicals. And again, it's quite a bit more complicated than this. And I'm certainly not a geneticist, but I do understand the basics, right? DNA is made up of what we call base pairs, and bases are things called nucleosides, things like adenine, guanine, cytosine. There's a couple more. Thymine is another one. And these things are woven together basically in an infinite number of arrangements to create the DNA and the RNA that controls life. And when we have oxidative damage to our DNA, it's like corrupting the software that runs the hardware, right? Free radicals can break your DNA strands, or they can remove or otherwise modify these nucleoside bases that are the fundamental building blocks of your DNA. And the result is that damaging your DNA changes your cell's function, right, for the worse, and corrupting the code or the software that controls what the cell does and how it does it. And this is why low-grade chronic inflammation is such a threat, because you can spend decades of your life trying to operate with damaged hardware using faulty software. And what I mean by that is that the inflammation and free radical stress that damages your cells and your DNA that controls those cells. So that would be like a hacker sending a virus into your computer to corrupt your software, but just for good measure, they take out a hammer and they damage the actual hardware too. That's the impact of stress and oxidative stress and inflammation at the cellular level. This is why so much focus has been placed on controlling inflammation in both alternative and conventional medicine. And obviously where we differ is how we identify and quantify inflammation, the tools that we use to control it. In my world, we use a wider list of tests that we can run commonly to find inflammation, referring to those acute phase reactants that we talked about before. And we prefer to find and fix the root cause, right? The thing that's creating the inflammation and the oxidative stress to begin with. And that doesn't mean that we don't make frequent use of natural compounds that are great anti-inflammatories or antioxidants, like things like turmeric, resveratrol, boswellia, ginger. All of these things have a very long history of use as anti-inflammatory compounds. And we use strategies like vitamin D and glutathione sufficiency to improve the function of your regulatory T cells so we can control inflammation that way as well. But sometimes just reducing inflammation by using these herbs is not enough if the thing that started the inflammation is still there. So if you find that you're using some anti-inflammatory strategy and that helps you feel and function better, but every time you reduce your dose or you stop, you feel bad again, that's probably because there's a root cause driving the inflammation and oxidative stress that you haven't identified and addressed yet. So that's a quick review of two sides of the same coin, inflammation and oxidative stress. Remember, they beget each other. And I'm going to have to split this episode up into two different parts. When we come back in the next episode, we'll actually talk about the oxidative stress test, what's in it, why it's important. We'll relate that back to damage to cell membranes as well as DNA. And then maybe we'll talk about some strategies that we can employ to fix what we find. All right, guys, if you haven't done so, please subscribe. I appreciate it. First of all, I appreciate the fact that you're listening. If you're interested, and I'll talk more about this in the next episode, but you can use the link in the description to get to my lab shop. This is basically an online place where you can go and order tests that I commonly use in my practice for yourself. You get it for pretty much close to doctor pricing, which is, let's call it wholesale. And then you can use that to make your own decisions in your own self-care. All right, guys, again, hit that subscribe button, share this episode with someone you know. Thanks for listening, and we will see you next time.